Welcome to this session on feature engineering with Data Wrangler, powered by Birdsey, your AI study partner. Like and subscribe for more exam prep, and don't miss what's happening in the lower corner. It could be key to passing your exam. Let's get started.
Domain 1. Data preparation for ML. Using SageMaker Data Wrangler for data exploration and visualization. What is the primary purpose of using SageMaker Data Wrangler for data exploration? Is it A, to deploy machine learning models, B, to simplify data preparation and exploration, C, to perform hyperparameter tuning, or D, to manage cloud resources? The answer is B, to simplify data preparation and exploration. SageMaker Data Wrangler is designed to simplify the process of data preparation and exploration, allowing users to visually inspect and transform data before using it in machine learning models. Which feature of SageMaker Data Wrangler helps in visualizing data distributions? Is it A, built-in visualization tools, B, automated model training, C, data labeling services, or D, cloud resource management? The answer is A, built-in visualization tools. Data Wrangler provides built-in visualization tools like histograms and scatter plots to help users understand data distributions and relationships.
Have you noticed the code in the bottom corner? Next time you're stumped, take that code to birdsey.ai for immediate help and a free study session with Birdsey, your personal AI study partner. Plus, you'll get access to hundreds of additional questions, helping you move closer to passing your exam with confidence. The next time you're feeling unsure or stuck, give it a try.
How does SageMaker Data Wrangler assist in feature engineering? Is it A, by deploying models, B, by tuning hyperparameters, C, by offering pre-built and custom transformations, or D, by managing data storage? The answer is C, by offering pre-built and custom transformations. Data Wrangler provides a variety of pre-built transformations and the ability to create custom transformations to aid in feature engineering. You are using SageMaker Data Wrangler to prepare a dataset for a classification task. Which feature would you use to handle missing values effectively? Is it A, data visualization, B, model deployment, C, hyperparameter tuning, or D, data transformation options? The answer is D, data transformation options. Data Wrangler provides options to handle missing values, such as filling them with mean, median, or a constant value, which is crucial for preparing datasets for machine learning tasks. Data cleaning techniques, missing values, outliers, deduplication, using Data Wrangler. What is the primary purpose of handling missing values in a dataset using Data Wrangler? Is it A, to ensure data completeness and accuracy, B, to reduce dataset size, C, to improve data visualization, or D, to enhance data security? The answer is A, to ensure data completeness and accuracy. Handling missing values ensures that the dataset is complete and accurate, which is crucial for building reliable machine learning models. Which method is commonly used in Data Wrangler to identify outliers in a dataset? Is it A, scatterplot, B, boxplot, C, line graph, or D, histogram? The answer is B, boxplot. Plots are a common method to visually identify outliers by showing the distribution of data. In Data Wrangler, what is the main goal of deduplication? Is it A, to increase data volume, B, to enhance data visualization, C, to improve data quality, or D, to anonymize data? The answer is C, to improve data quality. Deduplication aims to remove duplicate records to ensure data quality and integrity. You are using Data Wrangler to prepare a dataset for a machine learning model. The dataset contains several missing values. What technique should you use to handle these missing values effectively? Is it A, remove all rows with missing values? B, replace missing values with zeros? C, ignore the missing values? Or D, impute missing values? The answer is D, impute missing values. Imputation is a common technique to handle missing values by filling them with estimated values based on other data. Feature engineering, scaling, normalization, binning, log transforms. What is the primary purpose of feature scaling in machine learning? Is it A, to ensure all features contribute equally to the model? B, to increase the model's accuracy? C, to reduce the number of features? Or D, to improve data visualization? The answer is A, to ensure all features contribute equally to the model. Feature scaling ensures that all features contribute equally to the result, preventing features with larger ranges from dominating the model's predictions. Which transformation is typically used to handle skewed data distributions? Is it A, min-max scaling? B, z-score normalization? C, log transformation? Or D, binning? The answer is C, log transformation. Log transformation is commonly used to handle skewed data by reducing skewness and stabilizing variance. What is the effect of applying min-max scaling to a dataset? Is it A, it standardizes data to have a mean of 0 and a standard deviation of 1? B, it scales data to a fixed range, usually 0, 1. C, it reduces data dimensionality? Or D, it normalizes data to have a unit norm? The answer is B, it scales data to a fixed range, usually 0, 1. Min-max scaling transforms data to a fixed range, typically 0, 1, preserving the relationships between data points. A dataset contains a feature with a highly skewed distribution. What transformation would you apply to make the data more normally distributed? Is it A, min-max scaling? B, z-score normalization? C, binning? Or D, log transformation? The answer is D, log transformation. Log transformation is effective for reducing skewness and making data more normally distributed, especially for right-skewed data.
If you're finding this helpful, please take a minute to like this video and subscribe to our channel for more practice exams, useful tips, and complimentary study sessions with Birdsey.
Encoding categorical features, one-hot, label encoding, tokenization. What is the primary purpose of one-hot encoding in machine learning? Is it A, to reduce dimensionality? B, to convert categorical data into a numerical format? C, to handle missing values? Or D, to improve model accuracy? The answer is B, to convert categorical data into a numerical format. One-hot encoding is used to convert categorical data into a format that can be provided to ML algorithms to do a better job in prediction. Which encoding method assigns a unique integer to each category? Is it A, label encoding? B, one-hot encoding? C, tokenization? Or D, binary encoding? The answer is A, label encoding. Label encoding assigns a unique integer to each category, making it suitable for ordinal data. A dataset contains a color feature with categories red, blue, and green. Which encoding method should you use to avoid introducing ordinal relationships? Is it A, label encoding? B, binary encoding? C. One-hot encoding. Or D. Frequency encoding. The answer is C. One-hot encoding. One-hot encoding is ideal for nominal data as it avoids implying any order among categories. What is a potential drawback of using one-hot encoding? Is it A. It introduces ordinal relationships. B. It is not suitable for numerical data. C. It requires data normalization. Or D. It increases dimensionality. The answer is D. It increases dimensionality. One-hot encoding can lead to a significant increase in dimensionality, especially with high cardinality features. Feature splitting, combining, feature selection, and deriving new features. What is the primary purpose of feature selection in machine learning? Is it A. To increase the number of features for better accuracy? B. To reduce the number of input variables and improve model performance? C. To combine multiple features into a single feature? Or D. To split features into more detailed subfeatures? The answer is B. To reduce the number of input variables and improve model performance. Feature selection aims to reduce the number of input variables to decrease model complexity and improve performance. Which technique is used to derive new features by combining existing ones? Is it A. Feature engineering? B. Feature selection? C. Feature splitting? Or D. Feature scaling? The answer is A. Feature engineering. Feature engineering involves creating new features by combining or transforming existing ones to improve model performance. Which method is commonly used to split a categorical feature into multiple binary features? Is it A. Normalization? B. Standardization? C. One-hot encoding? Or D. PCA? The answer is C. One-hot encoding. One-hot encoding is a technique used to convert categorical variables into a set of binary variables. A data scientist is working with a dataset containing a date feature. They want to derive new features such as day of the week and month. What process are they performing? Is it A. Feature selection? B. Feature scaling? C. Feature splitting? Or D. Feature engineering? The answer is D. Feature engineering. Deriving new features from existing ones, such as extracting day of the week from a date, is a part of feature engineering. Using Feature Store and Data Wrangler together, manage in-feature metadata and feature reuse. What is the primary purpose of using a feature store in machine learning workflows? Is it A. Centralize feature management for reuse and consistency? B. Store raw data for pre-processing? C. Provide a user interface for model training? Or D. Optimize hyperparameters automatically? The answer is A. Centralize feature management for reuse and consistency. A feature store centralizes feature management, enabling consistent feature reuse and metadata management across different ML models. How does Data Wrangler facilitate feature reuse in a machine learning pipeline? Is it A. By automatically training models? B. By transforming data and storing features for reuse? C. By visualizing model performance metrics? Or D. By generating synthetic datasets? The answer is B. By transforming data and storing features for reuse. Data Wrangler allows users to transform and prepare data, which can then be stored in a feature store for reuse in different models. Which component is crucial for managing feature metadata in a feature store? Is it A. Model training logs? B. Data visualization tools? C. Metadata management system? Or D. Hyperparameter tuning module? The answer is C. Metadata management system. Feature metadata management is crucial for tracking feature lineage, types, and usage, ensuring consistency and reusability. A data scientist wants to ensure that features used in multiple models are consistent and easily updated. How can they achieve this using AWS tools? Is it A, by manually updating each model's feature set? B, by using separate datasets for each model? C, by employing a different feature engineering process for each model? Or D, by utilizing a feature store for centralized feature management? The answer is D, by utilizing a feature store for centralized feature management. Using a feature store allows for centralized management of features, ensuring consistency and ease of updates across models. Domain 2, ML model development. Impact of feature quality on model bias, variance, overfitting, underfitting. How does high feature variance typically affect a machine learning model? Is it A, it reduces model bias? B, it increases the risk of overfitting? C, it improves model accuracy on unseen data? Or D, it has no impact on model performance? The answer is B, it increases the risk of overfitting. High feature variance can lead to overfitting because the model may capture noise as if it were a pattern, reducing generalization to new data. What is a common consequence of using low-quality features in a machine learning model? Is it A, increased model complexity? B, improved generalization? C, underfitting? Or D, reduced bias? The answer is C, underfitting. Low-quality features often lead to underfitting because the model lacks the necessary information to capture the underlying patterns in the data. Which feature quality issue is most likely to increase model bias? Is it A, missing important features? B, high feature correlation? C, high feature variance? Or D, redundant features? The answer is A, missing important features. Missing important features can increase bias because the model lacks crucial information to make accurate predictions. A data scientist notices that their model performs well on training data but poorly on test data. What feature quality issue might be causing this? Is it A, low feature variance? B, high feature variance? C, balanced feature distribution? Or D, feature redundancy? The answer is B, high feature variance. This scenario suggests overfitting, which can be caused by high feature variance capturing noise rather than true patterns.
Notice the code in the corner? When you're stumped by a question, enter it at birdsey.ai for immediate help. Enjoy complimentary study sessions and access to hundreds of additional questions to help you pass your exam with confidence.
Feature engineering's impact on different model algorithm types. Trees versus linear versus neural nets. How does feature scaling impact linear regression models? Is it A, it ensures features contribute equally to distance calculations? B, it has no impact on linear regression models? C, it only affects tree-based models? Or D, it primarily affects neural networks? The answer is A, it ensures features contribute equally to distance calculations. Feature scaling is crucial for linear regression as it ensures that each feature contributes equally to the distance calculations, improving model performance. Why is feature selection important for tree-based models? Is it A, it is not important for tree-based models? B, it only affects model training speed? C, it reduces overfitting and improves interpretability? Or D, it is crucial for scaling features? The answer is C. It reduces overfitting and improves interpretability. Feature selection helps reduce overfitting and improves interpretability by removing irrelevant features in tree-based models. A data scientist is using a neural network for image classification. How does feature normalization impact the model's performance? Is it A, it has no impact on neural networks? B, it helps the model converge faster? C, it only affects the model's interpretability? Or D, it is only necessary for linear models? The answer is B. It helps the model converge faster. Feature normalization helps neural networks converge faster and achieve better performance by ensuring that input features are on a similar scale. What is a common misconception about feature engineering for tree-based models? Is it A, feature scaling is crucial for tree-based models? B, feature selection is unnecessary for tree-based models? C, feature engineering is irrelevant for all models? Or D, tree-based models benefit from feature selection? The answer is D. Tree-based models benefit from feature selection. Why this question may seem a bit tricky. Tree-based models are often thought to be unaffected by feature scaling, but they can still benefit from feature selection to improve performance. Cross-validation and feature evaluation techniques. What is the primary purpose of using cross-validation in machine learning model development? Is it A, to increase the size of the training dataset? B, to evaluate the model's ability to generalize to new data? C, to optimize hyperparameters automatically? Or D, to reduce the computational cost of training? The answer is B, to evaluate the model's ability to generalize to new data. Cross-validation is used to assess how the results of a statistical analysis will generalize to an independent dataset. It helps in reducing overfitting and provides a more accurate estimate of model performance. You are developing a machine learning model and notice that the model performs well on the training data but poorly on the validation data. Which technique should you consider to address this issue? Is it A, cross-validation? B, feature scaling? C, increasing the number of features? Or D, reducing the training data size? The answer is A, cross-validation. This situation indicates overfitting. Cross-validation can help by providing a more robust estimate of model performance and ensuring the model generalizes better to unseen data. In feature evaluation, why might a feature with a high correlation to the target variable still be excluded from the final model? Is it A, it increases model complexity? B, it reduces model interpretability? C, it may cause multicollinearity? Or D, it requires more computational resources? The answer is C, it may cause multicollinearity. Why this question may seem a bit tricky. A high correlation might suggest importance, but the feature could be redundant if it is highly correlated with other features, leading to multicollinearity issues. Domain 3, deployment and orchestration of ML workflows. Integrating engineered features into pipelines, example using Data Wrangler, Feature Store, training. What is the primary purpose of integrating engineered features into an ML pipeline using a feature store? Is it A, to centralize and manage features for consistency and reusability? B, to increase the speed of data processing? C, to automatically tune hyperparameters? Or D, to visualize data transformations? The answer is A, to centralize and manage features for consistency and reusability. Feature stores are used to centralize and manage features, ensuring consistency and reusability across different ML models and pipelines. Which AWS service is commonly used to engineer features before storing them in a feature store? Is it A, AWS Glue? B, AWS Data Wrangler? C, AWS Lambda? Or D, AWS S3? The answer is B, AWS Data Wrangler. AWS Data Wrangler is a tool that simplifies the process of data preparation and feature engineering before storing features. How does using a feature store benefit the training phase of an ML workflow? Is it A, by automatically selecting the best model? B, by increasing the speed of model deployment? C, by providing consistent and reliable features for training? Or D, by reducing the need for data cleaning? The answer is C, by providing consistent and reliable features for training. Feature stores provide a consistent and reliable source of features, reducing errors and improving model training efficiency. A data scientist is using AWS Data Wrangler to prepare features for a new model. How should they ensure these features are reusable for future projects? Is it A, by saving them in a CSV file? B, by documenting the feature engineering process? C, by integrating them directly into the model code? Or D, by storing them in a feature store? The answer is D, by storing them in a feature store. Storing features in a feature store ensures they are accessible and reusable for future projects, maintaining consistency. Handling streaming versus batch feature updates in production. What is a key advantage of using streaming feature updates over batch updates in a production ML workflow? Is it A, reduced computational cost? B, real-time data processing? C, simplified data management? Or D, easier to implement? The answer is B, real-time data processing. Streaming updates allow for real-time data processing, enabling models to react to new information immediately, which is crucial for time-sensitive applications. A company needs to update its ML model features every hour with the latest data from user interactions. Which update method should they consider for efficient processing? Is it A, real-time streaming updates? B, micro-batch updates? C, hourly batch updates? Or D, daily batch updates? The answer is C, hourly batch updates. Batch updates are suitable for periodic updates like hourly processing, balancing efficiency and resource use. In a production environment, why might batch feature updates be preferred over streaming updates for certain applications? Is it A, they provide real-time data processing? B, they are easier to implement? C, they reduce data latency? Or D, they are more efficient for non-time sensitive tasks? The answer is D, they are more efficient for non-time sensitive tasks. Why this question may seem a bit tricky, batch updates can be more efficient for non-time sensitive applications, reducing computational overhead and simplifying data management. Domain 4, monitoring, maintenance, and security. Monitoring feature drift and data drift in deployed models. What is a common indicator of feature drift in a deployed model? Is it A, changes in the statistical properties of input features? B, an increase in model accuracy? C, a decrease in data volume? Or D, improved model interpretability? The answer is A, changes in the statistical properties of input features. Feature drift occurs when the statistical properties of input features change over time, affecting model performance. Which method is commonly used to detect data drift in machine learning models? Is it A, increasing model complexity? B, monitoring statistical metrics? C, reducing feature set? Or D, enhancing data preprocessing? The answer is B, monitoring statistical metrics. Monitoring statistical metrics like distribution changes helps in detecting data drift. A deployed model's performance has decreased over time. What should you check first to identify if feature drift is the cause? Is it A, model architecture? B. Output predictions. C. Statistical properties of input features. Or D. Data storage format. The answer is C. Statistical properties of input features. Checking the statistical properties of input features can reveal if feature drift is affecting model performance. How can you differentiate between feature drift and data drift in a deployed model? Is it A. Feature drift affects model predictions directly? B. Data drift only occurs in training data? C. Feature drift is a subset of data drift? Or D. Feature drift involves changes in input features, while data drift involves overall data distribution changes? The answer is D. Feature drift involves changes in input features, while data drift involves overall data distribution changes. Why this question may seem a bit tricky. Both involve changes over time, but feature drift is specific to input features, while data drift involves broader data distribution changes. Ensuring feature data security, privacy, and governance, example, PII, encryption, IAM. What is the primary purpose of using encryption for feature data in AWS? Is it A. To ensure data confidentiality? B. To improve data processing speed? C. To enhance data availability? Or D. To simplify data management? The answer is A. To ensure data confidentiality. Encryption is used to protect data by converting it into a secure format that cannot be easily understood by unauthorized users, ensuring data confidentiality. You are managing a dataset containing PII in AWS. What is the best practice to ensure compliance with data privacy regulations? Is it A. Store data in a public S3 bucket? B. Implement strict IAM policies? C. Disable logging for data access? Or D. Use unencrypted data storage? The answer is B. Implement strict IAM policies. Using IAM policies ensures that only authorized users have access to PII, which is crucial for compliance with data privacy regulations. Which AWS service is primarily used for managing encryption keys for feature data? Is it A. AWS IAM? B. AWS S3? C. AWS CloudTrail? Or D. AWS KMS? The answer is D. AWS KMS. Why this question may seem a bit tricky. AWS offers multiple services that involve encryption, but AWS KMS is specifically designed for managing encryption keys.
Thanks for joining us today. If you found this video helpful, subscribe to our channel for more practice exams, tips, and tricks. And don't forget to visit birdsey.ai for complimentary study sessions with Birdsey, your AI-powered study partner.